right, in this one, we are asked to select all of the tables that are shown below. From the tables that are shown below, select all the ones that are functions, that represent functions. So a lot of times we learn to look for repeated x's, and if we see repeated x's, then it's not a function. And so if you go just based on that, and that's all that you really remembered from learning about how to identify functions from ordered pairs, you might choose, you might say that this is not a function because you've got 3 twice in the x column, and this one's not a function because you've got x equals 2 twice in there. Wow, what am I saying? I was just thinking, did I say x before? So let me just say that again to make sure my words made sense. I have 3 values, or 2 x values of 3 shown in the x column, and I've got 2 shown twice in the x column in the other table there. And so both of these I would rule out as functions if I was only looking for duplicate or multiple x values that were the same. These other 2 tables down here have no repeated x values, so I would probably choose those 2 and then submit and get it wrong. So how am I being tricked here? The reason it's not that simple is related to the idea of using the vertical line test. So, or at least I think it's easiest to understand if we think about the vertical line test. So what is the vertical line test? The vertical line test, which we sometimes write VLT for short, is the way to tell if you have a function when you're working from a graph. So if we had just been given the graph of these ordered pairs, would each table's ordered pairs pass the vertical line test? So let's go ahead and plot these ordered pairs. So that first ordered pair would be 0, -5. So that would be here on the y-axis at y equals -5. Then 3, 1. So I'm going to go to 3 for x and 1 for y. Then 5, 6. 5, 6. So 5 for the x and 6 for the y. Then 9, 8. So that's going to go all the way over here. And then 3, 1. So I'm going to go to 3, 1, and oops, I already have a dot there. So placing another dot there doesn't really change the graph. And then if I take a vertical line, let's say I just make a vertical line here, okay, and I'm going to just look for anywhere that this vertical line could touch more than one point at a time. So this vertical line was only ever able to touch one of my ordered pairs at a time. So this actually passes the vertical line test. Okay, so it's kind of a trick question, right? And let's try it again with this table here. Let's see, we'll do it in blue. So I won't write all the ordered pairs this time. So -2, -1, then 2, 3, then 2, 4, and right there you can see these 2 points are going to cause, like, I don't even really need to go any further. I just did those first 3 points, and I've already found a case or an instance where the where two of the points can lie on a vertical line at the same time. So this second one, the second table there, it fails the vertical line test, right? So that first table, some students say, hey, you tricked me. And kind of, yes, in a way, but also it's important because it's not just that we have repeated x values. It's more important to recognize that what really matters is if we have the same x value assigned to more than one y value, and the y values are different, because that is not a functional relationship. In other words, if I'm asking the question, if I start with an x value of 2, what should my y value be? Then I would not be able to give you a simple single answer. There would be a question mark as to which y value should be paired with the x value of 2. So that's what makes this relationship not a function, whereas this relationship, every time you want to know where where the x value of 3 will map to, 3 will always map to the y value of 1, or 3 will always be paired with the y value of 1. So there you go.